All right. Hi, everybody. Thank you for coming to our panel on the Composite Schemas Working Group. My name is Danielle. I work at Apollo as a Senior Director of Engineering. I've been working at Apollo for a little over 8 years. And I'm very excited to be chatting with this awesome group of folks today who represent the Guild, ChilliCream, and Apollo on the Composite Schemas Working Group. So would you like to introduce yourselves?
Sure. I'm Martijn Walraven. I've been with Apollo for a very long time, and I was one of the co-creators of Apollo Federation back in 2018.
And I'm Pascal. I'm the co-founder of ChilliCream. We were working on GraphQL Fusion since a few years, and now are also part of the Composite Schema specification, where we try to unify all our ideas.
Thanks. And I'm Kamil. I work at the Guild. I basically work on the GraphQL Hive platform, which involves the federation and like schema registry and stuff. So yeah.
Well, excellent. We have the exact right experts today to talk about everything composite schemas. So to kick us off, could you all tell us what is the difference between the Composite Schemas Working Group and the GraphQL Working Group?
I will take this one. That's an easy one. So the GraphQL Working Group does everything which is related to the GraphQL specification. And sometimes, because there's so much to do in the GraphQL Foundation, there are subcommittees which do certain things which are very specific. For example, there's the GraphQL over HTTP subcommittee, or there's the Composite Schema subcommittee. And this subcommittee now focuses only on creating this Composite Schema specification that defines how you compose a schema.
And how old is this working group?
This working group, I think it's probably now around a year, maybe a bit less, right?
There was a previous incarnation of it.
Yeah, true. Yeah, that's true. I forgot about this. I'm part of it since a year. But there has been this effort before. But then, as things are, sometimes it just died a bit down. But now we're going to finish it.
Full steam ahead.
Positively, yeah.
And what is a composite schema?
Yeah, maybe I can take that one. And that also sort of ties back to the previous incarnation of that working group, I think, because different people have a very different understanding of what a composite schema is. And in the most general sense, sort of when people originally conveyed this working group, they basically try to tackle all these issues at the same time. And you can imagine sort of locally composing schemas using sort of schema stitching-like approaches or federation. Those are very, very different approaches, and the goals are very different. And that was actually one of the things, some of you may have been at sort of my talk right before this panel, where I tried to go into a little more detail on what we mean by federation. And I think the reason the current version of the Composite Schemas Working Group is working so well is that we do have a shared understanding of the goals and what we're trying to accomplish here. I think we had a few different ideas like right at the start, but we quickly sort of resolved those, and that has led to some very productive work.
Yeah, it's multiple technologies that have evolved over the time, and now we start something new, which will be backwards compatible, but we start something new, where all the good parts are combined into one new specification. So even all of Fusion and Apollo Federation and the other parts, also what Mesh does, and the experience we gained through like all the different stitching solutions that are out there, really is a good base to create a shared understanding of what we actually need to solve this specific problem.
Yeah. Maybe we should be a little bit more explicit about what that specific problem is we're trying
Yeah,
to
what
solve.
is the current goal that you have from the
Yeah.
working group?
So federation, the way I would phrase it, but like might be good to also get other people's opinion on this. But the way I would phrase it, it's really about collaboratively working on sort of a shared schema. It's finding a way for larger organizations where you have like many different teams working together, many different underlying APIs and data sources, to sort of find a way for all those people to productively work on a single GraphQL API. And that's a really difficult problem to tackle. But we have sort of very principled way of thinking about this in terms of basically composing sort of different subgraphs, different sort of modular schemas together.
Yeah, it's like distributing the domain model of the company into different departments onto different services, and then having a way how you can actually access all the information in a company based on the domain model that you then compose together into one piece.
I also wanted to add that we talk a lot about like front-end teams talking to back-end teams, and with federation, it's actually forcing back-end teams to talk to other back-end teams. One example is if you happen to have a field that exists in both subgraphs, you have to have some kind of a contract saying, yeah, those are semantically identical, right? And that's the actually purpose of the shareable directive that is, I think, existing in both specs, right? The Apollo Federation and the spec we're building on the Composite Schema working group. Yeah, and I completely agree with the collaborative approach. So basically, the name of the type is a contract, the name of the field is a contract, the contract is also, like in terms of like Apollo Federation, the key fields. So how you actually contribute to a type, you define the requirements, how you, like what kind of fields have to be resolved in order to add another field to the type. So what is this contract between the types? We call them entities, but yeah. So yeah, that's basically it.
So
Maybe one last thing. You said about what we are actually building here, right? And maybe I've heard out of the conversation of us that it's about collaborating between teams and across services and whatever. So it's not a generalized solution how to do GraphQL or distributed GraphQL or something like this. It's a very specific way how we intend or how companies do it at the moment in production. And that's how we want to also use this, where this specification should build on top of. So it's not for everyone, but for the ones which already are known to the term federation, know the pattern, it's going to be something very similar.
So one single standard spec for how to compose schemas across multiple domains in a company that is maintained and loved and published by the foundation, open for everybody.
Excellent.
Excellent. Out of curiosity, how many folks here in the audience have used federated GraphQL in some capacity? All right, I think that's at least half the hands. This is probably a group of folks that want to hear a lot of details about what you're working on. So can you walk us through some of the concepts that are in scope in your discussions for the spec?
You start with it.
I can start with the easiest one, and then I will pass. So when dealing with like collaboration and like dealing with like contributing, or maybe like if you want to contribute a field to a type that is shared across different subgraphs, you need to have a way to communicate and resolve that field based on some requirements, right? In Federation, it's called entity, key fields of the entity type. In this spec, it's actually an argument of a regular GraphQL field of an object type. So imagine you have like a query type. It has a field called, let's say, user, and then it has an argument called ID, right? So it's completely compatible with the GraphQL spec, and in order to get it, in order to compose it with other subgraphs, you have to add a meaning to that field, right? You need to say, oh, it is actually the way we connect this type with the other type, and it happens to, go through that particular field of the query type. So you need to have a way to specify that. And the first directive that is the most important and will be the most commonly used is a lookup. So the lookup directive is a way to define this connection and I would say the transport of how do you contribute a field to certain types. So yeah, I passed.
Maybe to clarify, key is also still part of this specification.
Yes.
So key is important because it specifies a contract. It basically tells us that a certain entity can be identified through a certain combination of fields. The lookup is a way of actually fetching an object by such a key. But we actually had some discussions about sort of deriving keys from these lookup fields, but decided against it because explicitness is another important design principle that sort of underlies our work. It's important that you don't inadvertently sort of expose certain functionality or break functionality. And this, having both key and lookup, gives us sort of double bookkeeping. It allows us to sort of check these two definitions against each other and give you sort of meaningful feedback when you, for instance, haven't defined a lookup method.
Yeah, and just to also say something in this discussion, we also have a way to, when you have these lookups, it can be that you not just have a single field like an ID, it could be that the key is more complicated. It could also be that the key is nested, like we already have this now in Federation. You can have nested fields which are part of the key. And we have defined a way how you can map input types, how you can map output types to input types to express semantic equivalence. So for example, when you have an ID in a get user input and you have an ID on the user type, that you can express that these two things are actually the same thing. And with this, the query planning can actually plan based on what it can fetch this entity from the service. And for this, we have a whole specification written just for this specific new syntax. And that's already in. That's something you can also review on the repository.
Maybe that's a good setup to also talk about the process of validation, because all these different sort of directives and mappings and a whole different syntax in this case, these are not just sort of strings and things that might lead to issues at runtime. We validate these mappings against the schema at composition time. These are all things that are checked at build time, and they sort of have exhaustive rules that specify what combinations are valid and not.
Yeah, once it builds, it works. Otherwise, it's a bug.
Yeah.
That's a good thing.
We are getting a lot of really good questions from the audience, and we have 15 minutes. So I think I'm going to pivot to just peppering you guys with questions.
Sure.
So the first question is, can we expect a free and open source implementation of the spec for everybody to use?
Yes, multiple.
Say more.
I mean, I will talk about what we do, and then Kamil can talk about what they do, as well as Martin. So we have already a gateway which is called Hot Chocolate. And we do have an implementation of GraphQL Fusion, which is a predecessor to what we build now. And the idea is it's fully open source, it's MIT, the spec is under the foundation, everyone can implement it for free, and doesn't have to worry about any licensing or legal issues. And then we have these servers like Hot Chocolate, which will implement this spec. We're actually building the spec while we are building a server to verify that this also works, what we build. And so this is fully open source, fully MIT. Everyone can see the code and use it, change it, or ship it themselves?
Yeah, so from the guild's perspective, there are a couple of components here. So first one is the composition, right? That involves the validation. So that's something we have to build, and we will. We already have like composition for the federation, so we will just extend that. From the gateway perspective, we also happen to have a gateway. It's also MIT, blah, blah, blah. So the query planning logic will also be capable of running the new spec. Yeah, the validation, yeah, also part of the composition. So everything there will be supported. Yeah, and the query planning that we have that is existing in GraphQL tools is actually flexible enough to support all those use cases even today. But there's also one spec that, just to expand a bit, so part of the working group that we, part of the task that we have right now at the working group is also to introduce a new spec and pass it to another working group, which is managing the HTTP, is to have like variable batching and in general like more advanced batching that you used to. And that's also happened to already be supported. Maybe not completely, but like just to have some experiments in our like GraphQL yoga subgraph. So then we can have a place to actually play with different pieces and like, you know, continue evolving and being, you know, compatible with the spec and check if those things that we build in spec are actually, you know, making sense and are actually working as intended and, you know, being validated. So yeah, that's our goal from the guild's perspective.
Yeah, and I mean, we've had open source implementations of Apollo Federation going back all the way to 2018. The most recent generation is part of our Rust-based router, and that is likely going to be the code base where we would add compatibility with the new features.
The beauty of having so many solutions which implement the same spec is that we now have you now have the possibility to use the same technology on with the same specification on different stacks, which is good because then we can you can interchange you can change the tools as long as you use a server which also supports the composite schema specification. And this is really good for the ecosystem because it's all free. There's no vendor lock-in by definition because the specification is open source and everyone has to implement it, which is fantastic for the ecosystem. And what's even better for the ecosystem is that we can now run benchmarks across all the different servers and can compete with each other.
That's a great point. I love the excitement that you have for this and also the collaborative vibe that you'll have on this working group. I think that I'm going to sneak in a question from Martijn, which is, what will happen to Apollo Federation after this new spec is published?
Yeah, I mean, I would say that we're not really developing a new specification. And I know that's sort of a weird way of putting it because we are actually writing a new specification. But everything we're doing, and I think this is a result of sort of finding agreement on the underlying principles. All the work we've been doing so far is fully sort of backwards compatible with Apollo Federation. There are no breaking changes that we've introduced so far. We've made sort of additive improvements, and those, I think the work that was done on GraphQL Fusion has really sort of helped with those features, like with the lookup and with the new require mechanism. But those are additive changes. Those are things that people will be able to adopt incrementally, even subgraph by subgraph. And there's no need to sort of switch to those features. Like the existing Apollo Federation mechanisms will continue to work. And I think it's an open question sort of how we end up talking about this, because like GraphQL Federation is a sort of a shared core specification, but there are other things that are part of Apollo Federation, or at least that we currently consider part of Apollo Federation, that are outside the spec. So one way of thinking about this is that Apollo Federation would be a superset of GraphQL Federation.
Y'all have mentioned a couple times the lookup directive and the require directive. Are those the main two things that are pending in the spec right now?
Yes, yes. So, I mean, we're definitely, like we're spending a lot of time just sort of formalizing a lot of the things that we hadn't fully specified before, and finding a way to sort of make these understandable and
Yeah, I mean, it's the first specification that exists for, I mean, let's not count the diffusion one because part of it was moved over to this one, but it's the first really fully specified way, like a graphical specification, but for this composition. And while Apollo Federation works, it's somehow still difficult when you see a pattern there to express it in an algorithm or something like this. So this takes a lot of time and a lot of effort to have all these rules in place and create these rules, write the spec text and all these kind of things. Yeah.
yeah.
So I wanted to add one thing. We know that the popularity of Apollo Federation is quite huge, and introducing something that is backwards and incompatible is it's just wrong, right? It's like leaving you behind. So every time we have a conversation as part of the working group, based on the knowledge that we have, based on the set of tests that we created, and so on, we actually make sure that we validate multiple times if the rule that we're about to write is actually compatible with Apollo Federation. So we catch those if they happen. So that's something that you should be like pretty sure that it will be backwards compatible. It's just like a slightly different approach, but in slightly different with slightly different implementation. But that's like, as Martin said, it's just an addition to what is already in the Apollo Federation. So I wouldn't really worry about that.
So the money question is, how long do we have to wait for it to be formalized?
Well, there's no really a good answer for this. I mean, we make very good progress in what we do. We have specified all the directives. We have more or less, I think there's pull requests for most of the merge rules, validation rules, and then soon composition is finished and we can talk about satisfiability. And then once this is done, we have to see how much we have to specify in execution to make everything, to glue everything together and then actually implement it. The thing is that you never know what happens because we've seen it with defer and stream. You have something which looks very good. You work months and months on a specification for defer, and then someone finds something which is by definition a flaw and you change everything, right? We're pretty confident that this will not happen because we have so much experience now in the federation space altogether. But I don't think there's an end date.
No.
Or do you guys want to commit to a date? Like
Yeah. I mean, maybe one other thing is, as an outcome, we're also committed to a compatibility suite. And Kamil has been working on one for Apollo Federation. That's been very helpful. But we definitely want sort of one of the outcomes of this working group to be sort of an open compatibility suite that everyone will be able to test their implementation against. And I mean, we also want to make sure that there are multiple implementations out there before we sort of consider the spec completed. Yep.
I imagine you also want to have validated that the things in the spec will work in real world scaled use cases before you formalize it. So is part of getting that validation also a part of the formalization process?
Yeah, I think that's a tougher one because, I mean, as we've sort of emphasized, it's basically like Apollo Federation has been in use for many, many years at a very large scale. So I don't think we're as worried about the real world usability.
Okay.
But we do want sort of multiple independent implementations passing the compatibility suite.
yeah, and once it compiles, it works, right? So.
Can you describe what satisfiability is, please?
Oh, that's a good one for you, Martin.
Yeah, so basically the way we started thinking about this at Apollo, like initially, the validation rules we formulated were fairly ad hoc. We're sort of thinking about this at on a case-by-case basis. But what we landed on is basically a principle that we live by. We call it the fundamental property of federation. And it makes a lot of intuitive sense. It's basically saying that the supergraph schema, so the composed schema, any possible valid query against that schema, we should be able to satisfy that through a number of orchestrated requests against the underlying subgraphs. And I mean, there are different ways of formalizing this, but what it basically ensures is that no matter sort of how complex some of these composition rules are, you never want to get into a situation where composition succeeds, but there's a query that comes in that's valid and that we're not able to actually satisfy.
So satisfiability is like an algorithm that you run to make sure that the schema that you have defined through your directives will be perfectly executable by a query planner?
Yeah.
Cool. Well, we only have 2 minutes left, and there are a lot more questions here, so I would definitely encourage everybody that didn't get their question answered to come up and talk to you all. But there was one theme that we didn't really get to talk about that I think I'll just take the rest of our time for, which is how do you recommend folks create guidelines or support people in rolling out composite schemas in a case where multiple teams will now have to talk to each other? Like some of the human elements of working with a composite schema. Can you talk a little bit about the challenges there and some things that you've seen work?
The contract between the type is the name, right? But if, what if you could, like, I feel like there's this approach where it's actually easy to build subgraphs and makes things much easier, and you don't have to deal with like collaboration from the very, very beginning, and it's, you know, to avoid even the naming collision. So for example, you can have a user type defined multiple times under a different name, right? It will work. It's just happened that, you know, the type is different, like the name is different. Semantically, maybe they are identical, but you avoid the collision, you avoid the, you know, introducing new fields, etc. And maybe at some point you could think, oh, maybe it's time to actually merge the type that I created in my subgraph and put it under the same, let's call it semantical meaning, which means that the name of the type will be the same, and then you can deal with the, you know, then you can already see if the type and fields and all of that are actually working and validated in production, and then you can merge it if needed. That's like one approach. The other one, I guess you have to just deal with the collaboration. There is no other way you can like postpone it, but you have to talk, and which is a good thing, I guess.
Yeah, I mean, that's what I would say. It's actually, I would sort of slightly disagree with your first approach, because I think it's a dangerous one. Once you go down that path, like you introduce dependencies, clients start depending on those types. You're basically exposing details of your underlying subgraphs to your clients, and I would say, as a principle, that's not something you should ever want to do. Which means that you do have to deal with collaboration from the start, but I think that's actually one of the underlying goals of federation. The question then becomes, how do you do that? And that's something that isn't really part of the spec that our respective products, I think, are designed to help you with. Like we at Apollo, we support these different workflows where we help you with schema changes. We sort of validate changes that you've proposed against not just the supergraph, but even like the operations that people are executing against your graph. And that's a very common approach that people take. And with those sort of guardrails, I think collaboration is actually something that It's just a fact of life. You're working on a shared API, and you should sort of be prepared to have these types of discussions, to be aware of potential conflicts, and don't try to avoid them.
Yeah, and it's not necessarily just the dev teams that do have to talk with each other, because especially in bigger enterprises, there is some business team or multiple business teams that maintain the business side of things and basically are part of the stakeholder of the dev teams, or tell the dev teams what to do. And I think when you have such a collaborative approach, it's not only the devs that have to come up with the name which is equal across two different subgraphs. It's the whole business that has to lift this a bit, right? It goes a bit into these domain-driven design things and so on. It's like, if there is a type called user, this user has to be the same in both of the teams. There's only one user, and if the whole company lives by this, then it's much easier. You have this organizational structure that helps.
Yeah, and there is an abstraction boundary in place. Like that's like we're not asking people to change all their underlying APIs to be compatible. But what you're doing is as part of defining a subgraph, you define a mapping from those underlying APIs to the shared API that you're defining. And that's where you would resolve some of these conflicts.
The more successful you are, the more challenges you get to solve.
Yep.
Well, speaking of collaboration, if folks want to collaborate with you, how could they do that?
I mean, the easiest way to get started with it is to go to the workgroup GitHub repository. I think it's called Composite. It's under the GraphQL organization. It's called Composite Schema-WG, I believe, for workgroup. Schemas. Yeah. I mean, you will find it anyway. And then there is always an agenda of the next meeting, and you can write yourself in there as an attendee, and you can also have you can add agenda points that you want to talk about, and you can just join the effort. And we're happy to have you there, so you can come and be also part of this.
And see all our living rooms and bedrooms or whatever we take our calls
Your
from.
cats.
Yeah.
Well, is there anything you all wanted to share that we didn't get to cover?
No, I'm really curious about some of the other questions.
Oh my gosh. I mean, if we don't, are we going to get kicked out? I could just keep asking you these questions. In 5 minutes? Oh. Oh.
I think we would be.
In that case, we should take this to the hallway. All right. Thank you, everybody, for coming.